Yeah.
Okay, you should be live now.
Oh my God.
Yep.
Let's convene again on screen, gentlemen, from our homes using Zoom as yet another SBAU Astro Hour takes place, featuring the guys who love cosmology and astrophysics on screen from the Santa Barbara Astronomical Unit, Santa Barbara, California's longtime telescope club. We're fast approaching our fifth big year. I've been totally wrong, remiss, and not adding this up, and it went over your heads too. I've been saying 200 and something shows. Well, there's 52 weeks in a month and a year, and this is about to be our fifth year, starting in a couple of weeks. This is number 207. Our club is centered at the Santa Barbara Museum of Natural History, and I'm your host, Ronnie Herron. I'll introduce you to the rest of the guys on a morning when my voice is not up to speed, but that's all right. Captain Jerry will do most of the talking. We meet on the first Friday at the museum, and our topic will be beyond UFOs. Come join us, won't you? Here's what we're talking about this week. All seven of the fellow planets are lined up out there. We'll tell you where. Our moon is slimming down. It's on the waning side. The hell, it was waning here last week. Einstein first mentioned this. We are going to talk about it. Time dilation, or the other phrase, meaning if you can reach warp speed, doggone, you're going to outlive me. And what is a type 1A light curve anyway? We have a regular recurring novae, a binary star system ready to blow anytime. T Corona Borealis, everybody. And an important thing science knows about all the planets, the many moons, some asteroids, most comets, even exoplanets have in common water. I doubt there's that much on the sun, though. Let's talk to the group. Gentlemen, Jerry Wilson, you are still our beloved president, exalted
Good morning.
commander of the Starship. How things at your backyard, your little square box? You look out,
Good,
you go out there in the winter.
good. It's a cloud magnet, yes.
All right. And
I
Pat
think we
Porgy is his lovely wife. Chuck McPartlin is our outreach coordinator.
Morning.
He is married to Pat McPartlin, who holds down two other of the three uh, uh, offices, I guess, merchandise and wife. Oh, no, that's not an office. Treasurer. We got Tom Whittemore on board. Hello,
Morning.
Tom. He
Morning.
edits our newsletter, former instructor at Westmont, and he's married to Maureen. Bruce Murdoch is married to Bonnie, and he is with us, longtime supporter and telescope enthusiast. Tim Crawford not with us today, but we do have our regular rundown of sillies. Actually, we have more thought provokers this week. There was only a couple that might qualify cartoons. We like to start our show number 207 here for February 17th through the 23rd with these little thought-provoking items that Jerry sends to all of us. I notate them, and here we go. Are you in control of that, Mr. President?
I'm working on it.
One of them got a comment from Bruce that is worth repeating. Oh, here's the lineup of asteroid sizes versus consequences. My God, it starts with a 1 centimeter. That's nothing. Meteors. Okay. The other end, we have planet versus planet. My God, where did you get this?
Oh, it just cropped up. It's from that website XKCD that does highly technical um,
Sure.
cartoons.
Any of you want to pick one and make a comment? The
Well, they
size?
progressively go in size from 1 centimeter. Actually, the things you see in the night sky are the little fast white streaks that you see that go away real quick. They're about a grain of sand up to a centimeter. So these are definitely pretty. 10 centimeters and up to basketball size, these are called bolids. And you can see them, they last a long time. They're generally red. You can see them split apart. 1 meter, okay, news, unless you have expensive windows or are very unlucky. The Chelyabinsk was in the 1 meter to 10 meter range. Chelyabinsk.
It
That's the
was it
Russian.
was six it was 60 feet. So yeah, in the 10-meter range.
Yeah. Um,
Okay.
100 meters is bad, football field size is bad news, especially you live near the city it's aimed at.
Ooh.
And this is the size of the 2024 YR2. It's less than 100 meters.
What YR4?
YR4, thank you. 1 kilometer is bad news, especially you live on the continent it's aimed at. 10 kilometers is bad news for your species. 100 kilometers is bad news for your phylum. 100 up down here is bad news for your biosphere. 1,000 kilometers is good news for any life that might someday evolve on Earth's new moon. And at 10,000 kilometers, it's bad news for whatever planet is about to get hit by Earth.
No, we have two now that are threatening us, according to the scientists.
No,
Apollos.
they're near misses. Don't panic. The press is making sensations out of both of them.
Well,
Or
there
at
is
least
a chance. There's a tiny little, what, 2% that one of them,
there is a small chance. And the
Well, they
thing
don't
with the
really know
2020,
because the laws of physics don't really apply, but they don't, Kepler's equations, etc. Because meteors and so forth outgas, and they have little jets that go every which way, so they meander through. So you can't really predict where they're going to be until you get a lot of, it gets close.
yes, and we've only had a few short views of this 2024 one, and we can see it up till about another couple of months, I guess, and then it will be behind the sun, and we won't pick it up again till farther around in its orbit. So right now we don't have real accurate prediction of its orbit, but as Bruce points out, even if we did have an accurate, the orbit can change through outgassing or sunlight pressure over a period of time. But 2024, if it is going to hit us, it's going to it is, what is it? What was I going to say?
so it
It's
must have
not a
passed
planet
us.
killer, it's not a city killer. It's you don't want to be where it hits, but we discovered it too short a time after its potential close counter that we don't have time to deflect it. We don't have time to shoot it down. We are
Really?
unprepared. We need things in orbit ready to go.
Is
And
that
they have repurposed some emergency time, or time that is set aside for the Webb telescope to take a look at it. And they're going to look at it in infrared, which is much better for inferring the size
Right.
of the asteroid.
And
So
that's what they're after. It's an accurate view of the size.
is that the Apophos or is that YR4?
no, that's YR4. Apophis is not going to come anywhere close for centuries.
Oh,
Yeah.
is that right?
I mean, not hitting us. It's going to
Yeah.
come close enough to get binocular visible when it comes by in like 2036 or something like that.
Well, this cartoon is based on the economy, but it shows our future in caves again. Father is saying to his son as they're eking out a living. So then we decided not to do much to prevent climate change because it would hurt the economy. Doggone right. It's far more important. Here's a thought provoker. This one, this provoked a response from Bruce, which I will ask him to repeat if he wants. The greatest enemy of knowledge is not ignorance, it's the illusion of knowledge. Bruce, what did you send to answer?
Something I read quite some time ago. Those who think they know it all are an annoyance to those of us who do.
Yeah.
Well,
And this is from Stephen Hawking.
can you give an example of that?
Of
Other
what?
than the current administration, maybe in office?
Well, we're not going to get into politics too much here.
Well, I know, but I don't know what an example of that would be. There's a lot of people, I guess, that would qualify with, sure.
This is a restatement of the Dunning-Kruger effect. When you are completely ignorant of a field, you know so little about it that you don't know that you know so little about it. So it's
Okay,
people,
astrologers
someone
are
spends 10 years studying physics, and then he makes an announcement, and then some guy who did 10 minutes watching YouTube says, bullshit. So
okay, that's a thought provoker. Here's another one.
Now this will
hand
test your
on here.
knowledge of science fiction and fantasy. This
Yeah.
is a little known fact that before Thing was an actor, he was a stagehand.
Da, 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 da.
That's for you
Yep.
punsters.
Yeah, he also worked for old
The
McDonald
Addams
as a
Family.
foreman.
Yeah.
Teori Atom. I guess this is what, Italian?
I
The,
don't know. I don't recognize the language.
Well,
It's
how about the first guy's first name? Is it misspelled?
no, that's in that language, John Dalton.
Oh, okay.
So
He came
he
up with, I
viewed it
guess,
as a solid sphere of something.
right?
J.J. Thomson had the pudding model of it, that it was a positive medium. This is not a cartoon. This is actual historical
Oh, yeah.
evolution of our view of the atom. And it's filled with electrons in the pudding like raisins. Then we have the Rutherford atom, which was developed in 1911, that it had a core and it had electrons orbiting around it. Then the Bohr atom, probably the most used example in physics classes, and it's also wrong, but it illustrates a few things that are right. It illustrates that the electrons are in shells or orbitals, as it was called.
Different orbits.
And then Erwin Schrödinger's 1926 model, is the present interpretation that it is a nucleus, small nucleus, surrounded by a probability cloud for where the electron can be found. But the
Okay,
electron has no known diameter. It has a probability of being found somewhere.
and nowadays, I guess the quantum guys just consider it a wave, don't they?
Well, no,
This
it has particle nature and wave nature.
this is the quantum model at the bottom, Ron.
Yeah.
Mhm.
Well,
This first guy whose name is Jhon. There's a sheet metal company in town, Johnny Sheet Metal, and they spell it Johonnys.
That's also a pest control agency.
yeah,
Right, right.
All right.
well, electrons are traveling the speed of light, I guess. Here we go. It's
No,
not-
electrons do not travel at the speed of
No.
light. They have mass. They have rest
Oh.
mass.
They do have mass. Well, I think I finally figured this one out. We do pay a lot for our gasoline, don't we? Heat waves, droughts, floods, wildfires, sea level rise, melting glaciers, warming oceans, extinctions, and $5.30 a gallon.
Yeah, this is the non-direct cost of that.
Yeah.
And it's not just gasoline. It's it started at the Industrial Revolution when we started using a lot of coal, and we started using fossilized and non-renewable sources of carbon. And we've been packing the atmosphere with increasing amounts of CO2.
And the guy says, geez, the price of gas has just gotten so high. Yeah, right. Well, those aren't funny, but boy, they sure nail you. And my voice is in the shop. This loaner they gave me is never any good. So proceed without me. Mostly I'll chime in, I guess, if I can. A lot to learn. Okay. That's a
Can you
crescent.
see this?
Yep.
Uh-huh.
Crescent.
Okay. Well, among our roundup of planets this week, Venus is heading into inferior conjunction with the sun. And so it's a decreasing crescent. It's a very dramatic phase. You show it to the public about this time and they think, oh, that's the moon because it shows a phase. But no, Venus shows phases too. So does Mercury. But Venus can get very dramatic and it's a very pretty sight. You can even get it down to where because it doesn't transit the sun when it's in inferior conjunction, sometimes it passes below or above. And so you can sometimes get a view of its atmosphere all the way around it if you're lucky and you have the right equipment.
Got Galileo in big trouble.
Yeah.
Yeah.
Oh, yeah.
And this
So
is
Mercury is hidden deep in the sunset. We won't see that.
Right.
Venus is only up for a few, about 50 minutes or something, or an hour or two after sunset.
Yeah. Couple
You got to
hours.
get in there. It's best to view
Couple
Venus during the day.
which one are we watching there? Is
That
that
was
Venus?
Venus.
That
And
was
it's-
Venus. This is Mars. Mars is
Mars.
a month past conjunction, or yeah. It's in Gemini, and it's decreasing. It's now about what is it?
Between 1 and 2, maybe.
Yeah, magnitude. It's 1.1. Oh no, that's Castor and Pollux. Mars magnitude is minus 0.6.
But
I
it's
was looking
easy to
for
see
its-
because it's so red.
Yeah,
Yeah.
I was looking
it's-
for its size here, but I don't see I have that written down.
And
But
it's
it
been-
reached a peak at opposition of 14 micron, 14 seconds of an arc. So it's probably about 10 or 9 right now. It's shrinking.
Yeah. And it's clearly in retrograde, Jerry. You can see it's marching up into Gemini,
Yeah.
the other way. Yeah.
So it will reach its stationary point in its retrograde loop around the 24th of February.
Okay.
Could be a dumb question, but we never see Mars in a crescent form ever, do we? It's impossible.
No, our spacecraft do, but we don't.
Mhm.
Okay.
This is an
Very blown
excellent-
out.
Yeah.
Oh, this is blown out?
Yeah.
too
Yeah.
bad.
I think it's Jupiter. It looks like a basketball.
Here we
Oh,
go.
There we go.
Much better.
This is taken by Christopher Go. So it's Jupiter by Go. The great red spot is centered in it.
It's a not so great red spot these days.
Yeah.
No, also the red
orange
spot,
spot.
when I looked at it back in the 60s, the red spot was about this big.
Hmm.
Really?
So it shrunk and faded.
But somehow
Well,
they
it
out.
oscillates. It did get bigger for a while.
Yeah.
Yeah, it comes and goes.
Huh.
This is the configuration of Jupiter's moons from a planetarium program this evening at 8 p.m.
Okay.
So Io, Ganymede, Europa, and Callisto.
Wow.
Nice viewing through a telescope.
Mhm.
What does science call the bands? Just bands or levels
Yeah,
or
these are bands.
bands?
Belts and zones.
Belts and zones.
Okay.
Huh? Amazing. If there were minerals, it'd be strata.
Now, Saturn is about magnitude 1.1. It's about 2/5 below Venus in late twilight. It's getting lower every day. It's hard to see.
Yeah.
But this is the moon configuration for it at 8 o'clock tonight. I'm not guaranteed that you can go out and see it. With my horizon here, it's probably impossible.
Titan is further out.
Yeah.
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 Mhm.
That's where we're going, I think, isn't it?
Say that again?
Did we send a probe there?
Way
Yes,
back.
Yeah.
we landed on it.
Yeah.
Well, I know that was Cassini.
No, that was the Huygens probe, I think it was.
Huygens.
Huygens, yeah.
Yeah, that was part of Cassini, I think.
Yeah.
Yeah. So also Uranus and Neptune are both very faint. They're prominent in the sky, except for Uranus is. Neptune is, if there's any space left between Venus and Saturn and the horizon, it's dominated by Neptune. So that will disappear this month. Now this is what the moon looks like tonight at 8 o'clock. And so we've got a lot of nice structure here in the middle to look at. These three
Won't be up at
craters.
8 o'clock.
No. It's closer to midnight now.
Yeah.
Hmm.
And this doesn't look like the right phase. This
Yeah, I was going to say, when I looked at it last night, it was almost a full moon.
Well, it is closing down here. Let's see if I've February 17th, Monday, give us phase. well, I'm not going to spend time hunting it up on here.
Yeah, yeah.
But this is the one that the planetarium software gave me. If
Mhm.
it's wrong, I apologize for it.
Yeah, no, it may
But
be right.
yeah, it'll be later this week. It'll be last quarter. We're heading
Yeah.
in.
Mhm.
So,
Yeah, it looks like what I saw this morning.
okay.
Yeah, I was up at about 3 a.m. for an asteroid, and it looked kind of like this. Yeah.
Mhm.
How about how was the asteroid? Did you get an occultation?
It was a positive, yes.
Wow.
Okay.
And T Corona Borealis was a negative.
Negative, yeah. Now we're going to start talking about T Corona Borealis and the
This looks like a
standard
type
candle,
1A.
the type 1A supernovas that are a standard candle. The reason that they're a standard candle is that they all, if you properly normalize them, this is the magnitude and this is the time. And I purposely left the units off here because it's all really the relative shape of this when you normalize it that it becomes useful. That all supernova type 1As have the same peak brightness when they emit. And so you measure the brightness that it gets to. If you can find it soon enough, you can figure out when it went to the peak. And you can measure its you can measure its apparent brightness, and then you know the absolute brightness. And so from the inverse square law, you can tell how far away this thing is.
Mhm.
Now, also, when we're looking way back at the beginning of the universe, that part of the universe is expanding at very close to the speed of light, if not faster than the speed of light, because the universe is expanding. So the star is actually rushing away from us. And because of that, we can see time dilation in the star's spectrum too. And that means that this time scale is now spread out. So where this would normally take a few days to go down, and this is in days on this chart, I believe. This would take actually up to 4 years to do this because time is slowed down. So it goes very slowly for things that are far away from us and moving fast. So you can tell how fast it's going, and you can get its redshift, and you can couple that in with its speed and distance. So this is a standard candle for that. And that's why these are so important. And we like type 1As.
Mhm.
There are a number of different types of nova, but they don't all perform in this textbook way. Just the type 1A does. And we're about to get a type 1A in the form of a recurring supernova.
Well, wait. No. It's not a supernova, and it's not a type 1A. It's a
Okay,
recurrent nova, but it doesn't
recurrent. Yeah,
destroy the white dwarf,
yeah,
which is what a type 1A does.
Mhm.
yeah. Okay. So thank you, Chuck.
Mhm.
So this is a pair of stars. This is a red supergiant, and this is a white dwarf star that is close, that they are close enough to each other that the outer reaches of the red giant is having hydrogen torn off of its atmosphere, and it's going around through an accretion disk, and it lands on the white dwarf. And so as the material accumulates, it builds up to a critical mass because it's compressed very much because the white dwarf is very small. And when it builds up enough, then it starts fusing. And that's what we see as a nova.
Really?
And it turns out that we also get recurrent novas. Whoops. Now this one, can you see this? It's pretty white.
Mhm.
Okay. This is in Corona Borealis, the constellation. Here's the keystone of Hercules and M13 noted here. This is the crown of Corona Borealis. And in this red dot is T Corona Borealis, and this is the location for it.
Mhm.
So it's right off this star, Epsilon, up from Delta and down from Iota. And that's what is possibly going to detonate here. Dang, I got to go back to the other now. This is not doing the progression.
Those accretion disks are all flat, aren't they? They're not a shell.
They can
Well,
be donut shaped on the outer part, but
yeah. Eventually, everything in the accretion disk lands on the surface of the white dwarf. It's not the accretion disk that explodes. Is
But
this
for
too washed out?
we're not seeing
Okay.
it.
Oh, you're not seeing it. Okay. So I take that as a yes.
Washed out in the other direction.
Open with things move around here. Okay.
There we go.
Okay. So this is according to Julian dates, which is counting days from a certain epoch. 2008, 2009, 2010. This star is a Cepheid variable. This is its variableness. It doesn't change by much. It goes from 10.6 to about 9.9. So by a fraction of about 7/10 of a magnitude, which is quite hard to spot visually, but a lot of our equipment will get it. And then this is what happened in 1946 when it went off. This is the same star, and its Cepheid variableness is in here. So this is what's called the pre-eruption dip, which happened in 45. And we've seen this last year. This was about April of last year. And then about 12 months later, because this is May, and then this is February. So about, what is it, 6, 7, 8 months later, you got this explosion on the surface of a nova outburst. And then the decline back down, and then up again, another little rebound from this star. And that's what we're expecting to see. So we believe we're now down here. And the looking at it spectrally, which I don't have to show you, but spectral analysis shows that the flow of hydrogen is increasing all of a sudden, leading to possibly an instability. Now, this is a note for those of you that have a question about what Julian Day is. So it's a date it's a calendar that's made so you can do simple algebra with the date. So it's a decimal date, and it counts days from noon on Monday, January 1st in the year 4713 BC. And that tag keeps coming up. And the Julian day is counted from 12 o'clock Universal Time on for an example, January 1st, 2000 was, let's see, 2,451,545. So that's the Julian day that corresponds to January 1, 2000.
At noon, yeah.
So
what's the alternative?
the alternative is your regular Gregorian calendar.
Gregorian, okay.
But this one is made so that you can do simple math, because you don't have to figure out how many days were in each month, how many months went by. You just simply subtract the days. And it's used by astronomers and I believe other people that I've forgotten what it is, maybe geologists. So anyway, this one, what's that?
Is the Julian named after Caesar?
Yep.
Yes.
Okay.
He was called Julie for short.
Julius Caesar. Yeah.
So this is Caesar Julius. Yeah. So this is a T Corona Borealis finder chart. It's a nice finder chart, so I put this up. But this thing is from 2024, the astronomical lead, and it was estimating that between now, which was early 2024, and September, T Corona B is predicted to nova quickly. So they missed it. It's going to happen this year, and it's going to happen soon. But it's got a nice finder chart in it. Here's a 6-degree field of view. Now your field of view in a telescope that we use is probably going to be closer to one of these circles. So in Corona Borealis, you can get on epsilon right there, and that's epsilon. And then you can move down this way from north. You can move directly south, an easy movement on an equatorial mount. And you can move down to here and then move over, and there you are on T Corona Borealis. T Corona Borealis is about magnitude 9, I think, right now. Is that? Star's normally magnitude 10.3.
But there are other stars up there that do this?
Yep.
There are a couple. They're not common.
Really? So Cepheids, huh?
No, it's not Cepheids. It's the fact that it's a recurrent nova.
Yeah, there are
Okay.
Cepheids up there too.
Cepheids are pretty common. I don't think this is a Cepheid variable, being a red giant like this, but
Yeah. Oh, well, this isn't the red giant. This is the little one.
well, yeah, when you were describing T Coronae Borealis, you said that the host star there that's getting the material siphoned off of it was a Cepheid variable. And I don't think it is, but it is a variable star.
Yeah, no, I thought the whatever is the dominant light source that you see, the claim is that's a Cepheid variable.
Yeah, I don't think it is, but
Okay.
Well, you know, Tom Whittemore once gave us a speech
Uh-huh.
about Cepheids.
Yeah,
Right.
and
Short
we'll do it
period.
again.
Yeah. Short period. Cepheids.
Does this star have is it in anybody's catalog?
T
Does it have a
Corona
catalog
Borealis, it's
name?
in the AAVSO catalog.
Yeah.
Okay.
Yeah.
Ocean worlds. Boy, we're off of the star now, aren't we? And onto something else.
Usually a star that's as bright as 10.2 or 9 magnitude would be in several catalogs.
Right. And it tells me because it's T, it was the third cataloged variable star in the crown. So it starts out R, S, T, goes U, V, etc.
Okay.
That's how they know. That's how they count them.
Now
And some
we're going to
constellations,
switch
it's up
topics
to-
here. You'll hear from T Corona Borealis next when it blows up.
Yeah.
Mhm.
So we're going to talk about water in the solar system primarily. And it's all over the place. Water is copiously produced in nova. There's a lot of water signatures in that. There's a lot of raw water molecules just floating in space. And when things are made, it's usually part of the accretion disk, and it gets incorporated into a lot of planets. Some planets may be mostly water, or at least have an ocean under the surface. The ones that are, this is listed in the things that have less water than Earth down here, and things that have more water than Earth up here. And so Earth has a surprisingly small amount of water compared to other worlds. It's probably as a result of we were hit by Theia. And who knows what went on there. So Europa in our planet, in our solar system, and this is of interest because we're trying to find if a history of life in our solar system. And the idea is that water, as life as we know it, exists where there is water. And so several of these things have oceans underneath of them, underneath the surface. And there may be life existing in those things.
Why do we see two balls?
Oh, this is Chuck, you want to go ahead?
I was just going to say, one is the object itself, and the other one is the amount of water that's on the object.
Oh,
Right.
I see. I got you.
So if you took all the water on Earth and put it in a ball, it would be like this. So the Earth is pretty much a dry planet. This is not enough water to ever, under any circumstances, cover the Earth. So Noah's flood was a physical impossibility. Noah's flood is simply wrong. It's myth.
Yeah, but they only had a small view of the whole world, and it may have flooded where they were.
Yes, that's right. Probably right. They may have had one hell of a flood locally.
That was the Black Sea event.
Yeah, that's
Yeah.
my view also, that a natural dam broke, because you can find villages on the bottom of the present Black Sea.
Well, the Black Sea was a big chasm at one time,
No, it was a big valley.
a big
Yeah.
valley. Okay, and I guess the Mediterranean broke through the Dardanelles Strait, didn't it?
That's
Mhm.
very likely, yes.
Wow.
So anyway, all these other places have more water than we do. We may have had a hell of a lot more water at one point, but that's again speculation. This one is Triton, not to be confused with Titan.
Yeah.
Triton is a moon of Uranus. What is
Neptune.
it? Neptune, yeah, thanks. Callisto is a moon of
Jupiter.
Jupiter. Ganymede is Jupiter. Titan, Europa. Yeah, I guess there's no moon of Saturn here.
Titan is a moon of Saturn.
Right.
Oh, yes, of course, yes.
And so is Enceladus at the other end. And Dione.
Oh, yeah. Okay, good. I need more coffee.
Can I interject a dumb question?
Go ahead.
This just occurred to me. If
But
there were
remember, I get to give a dumb answer.
well, they're always dumb when they come from me when I have a voice like this. It occurred to me that if there were giant Jupiter-sized planets out there in space that were made of just water, we wouldn't be able to see them. We may not know they're there, but if they were to collide with a red dwarf, they might put it out
Put it out.
because water
It's not
does
it's
it.
not a chemical fire going on in stars, Ron.
Well, it wouldn't douse fusion or
No.
fission.
No.
It wouldn't.
There
Just
was
curious.
there was an experiment that everybody did in high school physics called calorimetry. You take a beaker of hot water and a beaker of cold water, and you had to calculate the temperature of the combined amount once you put them together. And the formula is really simple. It's that the heat is equal to MC delta T, which is the mass times the coefficient of thermal capacity and the temperature difference. But that way it would change the temperature of the combined thing, yes.
Really?
But
As
but
long
as
as
Chuck
they're
pointed out, it's not a
they're both
fire, you're not going to
liquids.
put it out.
Bruce, what did you
I
say?
said as long as they were both liquids. But you put some ice in there, and then you have the latent heat of fusion that you have to worry about.
Huh.
It takes
Fascinating.
energy to melt ice into water at 32 degrees Fahrenheit.
Okay.
And then on the
So
planet,
this is an example of a mapping of hydrogen at the south pole of the moon. And hydrogen here represents water. So this is a version of water that is somehow in these craters at the South Pole that are permanently in darkness.
looks
Why
like our
doesn't the water
astronauts.
evaporate?
What's
What?
that?
I said, why doesn't the water evaporate?
It's frozen and it's like, you mean sublime. Yeah.
Yeah, sublime. Right.
Yeah. So it's held, it's got inclusions in it so that it's like an antifreeze.
Uh,
And
So
it's
our
covered with
astronauts,
soil, most likely.
our future astronaut visitors will never go thirsty.
No,
And that's probably how it got where it is now. It was somewhere else on the moon, but the temperature differences there allowed it to sublimate. It formed a very thin atmosphere and moved through the atmosphere. And when it got to one of these places where it's cold all the time, where it's always in shade, then it congealed out.
right. It's
condensed.
called cold trapping.
Yeah.
Yeah, like a vacuum pump.
Yeah. And the moon, despite common belief, the moon does have an atmosphere. It's made primarily of rocket fuel exhaust.
Wow. And getting worse.
Yeah. Now, this is a picture taken by the Hubble telescope. I've lost my cheat sheet here. Of Europa. And this white splotch over here is actually a geyser. And the surface structure looks like fissures that froze, that water welled up into, and then they froze. So this has quite a substantial ocean underneath of it. And we have been warned in 2001, A Space Odyssey, to stay off it. but we're going there anyway, and we're going to drop a probe on the surface and try and melt through the ice.
Ooh, that geyser is like Old Faithful, or is it ice?
Well, I don't know.
water.
It's definitely going into a vacuum. It probably is freezing right away, so it may be just like a flurry, what's that, slush storm.
You ever seen what boiling water does when you throw it into frozen air or in the north latitudes? Wow.
Turns into a big cloud and freezes.
Yeah, it's fascinating.
Yeah. Now, these are pictures taken from, I believe it was Cassini, water vapor geysers on Enceladus.
Oh, not Europa.
But
No,
similar.
Europa was the previous one. This is Europa. It will
Okay.
have these things too, and this was one seen by Hubble.
We
This
gotta
is
make
one
sure.
seen by a spacecraft at Cassini, I believe.
Got to make sure our landers don't land on one of those suckers.
Oh, I think they'd love it if they did.
You think so?
Scoop up the samples.
They have to have a windshield wiper.
Right. So this is a projected cross-section of Enceladus. This is a very thick ice layer. These are pockets of water that form near the surface. There is heat up down here that causes the water to be, or the ice to melt in certain regions that produce liquid, and the pressure and the heat forces it up and into a geyser that comes out. But it's substantially thick. And you notice the ocean, in this case, for this drawing, the ocean does not extend over the whole moon. It's a regional thing around the hot spots. And these hot spots are caused by tidal forces happening in the moon, where the moon is frictionally heated in its orbit.
And they occur in those areas called tiger stripes that are showing up as light blue stripes there.
Yeah.
But
And
the
these
center is
things over
still
here.
rock.
Yes.
Okay. You don't suppose there's such a thing as a whole moon that's made of total water? The middle would
No,
be
the
like
whole moon has a rocky core, and it has ice on the surface.
Callisto is the closest thing to what you're talking about, Ron. We think it's undifferentiated, so it's just like a dirty snowball, but it's rocks and ice. But it hasn't uh, precipitated out with the heavy stuff in the middle.
Yeah. Now this is a cutaway view. Obviously, around the backside, the moon doesn't look like this, but this is Titan, structured from what was the name of the one that went by? It's Cassini. Yeah. So organic rich atmosphere on the surface, it's hydrocarbons. This is a decoupled outer shell with water ice and clathrate. I've never seen that term before, but I guess that's
a semi-solid mixture of methane and water ice.
Yeah, okay. And then the global subsurface ocean. Now here, the ocean subsurface is planet wide or moon wide. And underneath of it is a high pressure ice shell, and then a hydrosilicate core, about 2,000 kilometer radius, about 4,000 kilometers in diameter.
which goes to the center.
It has water on the surface in the form of boulders and mountains and stuff. And someone asked a question or something, ready to comment?
I remember the Huygens touching down.
Yeah.
And there were, I thought, what were rocks laying nearby? Those were ice.
Those were ice boulders, yeah.
Now, my question about liquid methane, it gets that cold that methane, which is a gas here, becomes a liquid. Does it ever get so cold that methane solidifies into something like its own cubes?
Yeah.
Ice cubes?
Yes.
Does it get?
In fact, Titan has a whole hydrological cycle involving methane. So it's like here where we have water that can be a gas, or it can be solid, or it can be liquid. The same thing happens with methane on Titan.
Yeah. Now,
But they have different temperature levels, don't they?
Yeah.
Our speaker Friday talked about liquid xenon buried in that mine shaft in South Dakota. What if it were solid xenon, so cold that it solidified? Wouldn't they have better chance of hitting the WIMPs, or had the WIMPs hitting an element?
They'd probably have a harder time detecting the flashes of light.
Yeah.
Oh,
You would have
okay.
to you would have to refrigerate the xenon to keep it solid. And that's a
We,
pretty low
we have to
temperature.
refrigerate it anyway, right, to keep it liquid.
Yeah, right.
Yeah, so anyway, to keep it solid, you'd have to cool it down, and the cooling system would cause vibration and interfere with your measurements,
Oh,
would be my guess.
so do they consider Titan a water planet or a water moon rather?
To this extent, yes.
I'll be darned.
It's not a water world like in that movie.
It's a frozen water world with
Yeah.
methane. You suppose there's more methane than water, or do they know? Trident.
Now, as for Triton, don't confuse it with Titan. There is a exploratory plan being formed to investigate Triton's subsurface. And the subsurface will not be drilling into it. The subsurface will be orbiting it and feeling the gravitational field around it. So it is believed to be covered with an icy shell. And the question is Triton an ocean world? Does it have an ocean? This model that's represented here is one of the possibilities. So it has not been established that there is water in it.
Wow.
Liquid water. Yeah.
But they do see ice volcanoes, and there is ice on the surface.
And those plumes are nitrogen. So there's also nitrogen ice.
Yeah.
I read somewhere that
And Pluto too.
I read that the Eskimos have what, 13, 14 different words for water. It comes in snow and ice and sleet. And
Yeah.
is there such a thing as snow on other planets and moons?
Sure.
Really? It snows?
Well, that's what happens in Pluto's atmosphere when it's far from the sun.
If you take snow as being water snow, then there is cases of that. But if you generalize it to flaky solids coming out of the air, there are planets that have that rain or snow iron crystals.
So the heart on Pluto is frozen nitrogen ice.
Yes.
So it snowed ice, nitrogen there.
Well, okay.
Now, as for the dwarf planets around us, Vesta, Ceres, and Pluto, this is a spectroscopic determination of the Mount. We've orbited both these asteroids. And Ceres, I believe, is a dwarf planet. Vesta is not. But by weight, it's estimated that it is 4%. Well, this is weight by percent. So this would be 0.04%, unless it's just the fraction. And then it's 4% by weight. Here, hydrogen weight by percent is, and that represents water on Ceres. It's up to 3.2%. So that's a significant amount of water on Ceres, but Vesta is considered to be a non-water world.
Huh.
Now, this is an enhanced photograph of the asteroid Ceres, and these bluish white things are especially this one is very bright, and it is considered to be a salt that is left on the surface after water has sublimed away. And it came from the interior where it has a very salty ocean underneath. What's the name of this crater again?
Akator.
Okay. That'll be on here. We have a close-up of that. Whoop. Okay. Got to go back to the other.
Salt. NaCl, sodium and chloride gets
No,
together.
We're using
No.
salt in a much more general way.
Oh, I see. So it's not table salt.
No.
You get salts when you mix an acid with a base.
Oh, okay. They
You know, you
don't
get a
cancel it.
reaction.
They don't cancel each other out.
Right. Well, not always, but one of the products of mixing an acid with a base is the salt.
Yeah.
Okay.
So can you
It's
see this?
Yeah.
Okay.
great skiing.
This is the ice volcano, whatever Chuck said, Ocatello,
Okator.
Okator. This is a close-up of that crater with the ice volcano inside and very enhanced, exaggerated color from that.
This is
So
on series.
these are the salt deposits that came from the ice volcano.
Wow.
So the people that are selling pink salt as a health benefit would love this.
Yeah.
Oh, yeah.
So most of this water,
I don't know where they get pink salt from. I think it's you can when you fly up to San Francisco on a plane, you come over to San Francisco International and you come real low over the South Bay frequently, and you see all these areas marked off in the South Bay where they're letting water evaporate to produce salt, and they're in different colors.
The
And
Leslie Salt Company.
I think that it's like Yellowstone, where the color of the basin with the geyser in it is due to the bacteria that's living in it. So
Right.
I tend to go with white salt and not with pink and blue salt. And
Well-
now they have black salt, I've seen.
are most of these water bodies you're showing us throughout the solar system salted?
Yeah.
What the water, they're telling it the hydrogen is there. That's really what we see, chemically, with our instruments. And the hydrogen is only going to be there if it's in water. But there's also a lot of other crap. It's not spring fresh water that they're going to bottle and sell directly.
There's minerals in there.
No, we're going to have to purify it. And people are looking at it mostly for a source of oxygen for breathing and for rocket fuel for hydrogen and oxygen.
Not to mention life.
Yeah.
Maybe little squigglies in there. Wow. Well, this looks like a great place to ski.
Yeah.
So go skiing this fall.
Now,
Here we go.
last but not least, this is
Certainly water.
Comet Atlas.
Yeah.
Sushinshan Atlas. And this is obviously a source of volatile materials, including water ice, methane ice, water ice. You recall the time that Sean Kelly came to our meeting and gave a talk, and he made a comet up in
Oh, yeah. Yes, I remember that.
Yeah, and he took liquid nitrogen to freeze water and methane mixed together, and with a bunch of rock and sand, and he passed it around before it thawed out. So
I don't remember that.
that was a great. Those are the kind of demonstrations that kids will
Yeah,
remember.
right. People understand them.
Yeah. Now this is a good photograph of the comet, and right in there is a very nice globular cluster, not associated with the comet. The comet just passed in front of it.
Oh,
And I've sort of memorized M13, and this is not it. So
all that H2O disperses in space and never separates back into oxygen and hydrogen, you suppose?
Sure it does. If it
Yeah.
gets hit with ultraviolet light.
yeah,
Well, it probably does a lot. Okay.
and the sun pumps out a lot of energy in the solar wind, which is primarily protons and electrons, but mostly protons, and a lot of photons. And then when it hits a chemical bond, it can break it.
Huh. What else? CO2 comes out of a comet?
Carbon monoxide, carbon dioxide, all kinds of stuff.
Water vapor.
Ammonia.
Yeah, methane.
Yeah.
Well, I wonder what causes the elements to get together in the first place. They're not created in stars like the elements, are they?
Yes, molecules are created in the star explosion. Yes.
Oh, they are? The molecules
And
themselves.
in the atmosphere of really cool stars.
Yeah.
Okay, but if an element of sodium gets close to an element or an atom of chloride, they just naturally get together and become salt.
Yep.
That's how it works. The same with
Because
CNO.
that's an exothermic process. It gives off heat when that happens.
Okay, but they're attracted to each other.
Yeah,
Nothing
well,
forced.
gravity sucks.
That was a famous line in a 60s movie. I forget what the movie was, but someone had carved in an apple, "There is no gravity, the earth sucks."
And of course, as Bruce said, those of you who think you know it all are very annoying to those of us who actually do. The
Yeah,
great
that's
line.
not me. I'm painfully aware of what I don't know.
That's not my quote. I found that someplace.
Yeah.
I know I've heard it before, but this is the only thing that makes it common is that it lets loose gas. If it didn't have gas to let loose, it would be an asteroid, right?
When
Yeah.
it there's a fine line, or I
Yeah.
guess a very blurry line between
Yeah.
asteroid and comet. So
Mm.
if it produces a dramatic tail, it's a comet. Comets were referred to as bearded stars up until recently.
Or hairy stars, yeah.
Yeah, hairy
And
stars.
even a rocky asteroid, if it gets close enough to the sun, is going to start giving off stuff.
Yeah.
Volatile depends on the temperature quite a bit.
But in the 3 minutes left, can I have an answer to this question? Some comets, if not all of them, have two tails, maybe three, right? Are
Yeah,
all of them?
you
Are all
see
those
two here.
okay? Are those two the same stuff?
Yeah.
CO2 and water vapor
Yep.
going?
All came
Well,
from the comet.
Well, what the types of tail you usually see are an ion tail and a dust tail.
Right.
The dust tail can show up in different ways. So that's you might see two dusty tails and one ion tail.
But as far as dust itself, little particles, little solid
Ooh,
particles get emanated from the rock
Yes.
like the water does.
Yes.
And they're freed by the heat of the sun,
Yes.
pretty much. Interesting. And that process just doesn't happen to asteroids as a rule.
It will if they get close enough to the sun.
They sort of become a comet. They'll get a tail.
Yeah.
Wow.
Or debris spalled off of them. The Geminid shower comes from an asteroid called Phaethon that's mostly rocky. It's like a dead comet, and it actually spalls off chunks of rock, and that's why you get a lot of fireballs in the Geminid shower.
Well, I'm just wondering why we don't have more well-known comets. So the only one world knows about is Halley's, and it doesn't seem to be any more outstanding every 80 years than the ones we get in a row. Every year we get, what, a dozen in a row, almost one a month. This is Sushinshan here, right?
Yeah,
yes.
but see, it's not periodic. It's not going to come back. That's the thing about Halley's Comet is that you see it every 76 years.
It's not going to come back. It's not in an orbit.
Tushanshan Atlas is probably not going to come back for hundreds of thousands of years, if at all.
Yeah, well,
Very elliptical.
one of them was measured as 80,000 years, and they still
Yeah.
call it the comet. Wow. Well, gents, have we done it? Did we do another one?
Well,
How do you summarize type 1A light curve? Did you cover that, Jerry? And did I miss
We did
anything?
cover the 1A. As an example of a nova, that's a supernova. But the
Right.
reason that we covered it was a brief interlude on its own topic.
well,
Don't
well,
confuse it with
also you kind of
CQ.
covered the time dilation in the type 1A supernova curve.
Yeah.
Well, time dilation, I thought was the faster you go, the slower time goes. You can outlive
Yes,
everybody
yes,
back on.
yes. And the
This,
light curves of type 1A supernovae show that. That's what Jerry was talking about, how it could take, multiple
yeah.
years, whereas here it takes weeks or months. If you see a close by type 1A supernova.
Yeah,
And
the decay.
And T Corona Borealis went off when I was born, 46. And we know that 80 years before that it did too again earlier.
I don't know that we know that. There is one other, I think, measurement of it somewhere or mention of it. It wasn't finally measured.
Okay, but you get
Just to get back to Tom Whittemore's thing that he wanted to talk about, there is a play going on down in Ventura at the Rubicon Theater called Constellations. Um, Opening night is February 22nd. Starts at 7 p.m. So I guess, contact the Rubicon, rubicontheater.org if you're interested in going and seeing that.
And you got 2 tickets, right? You and your lovely lady Maureen can't go. Well, we'd like to get a
Well-
review of it. Hope it goes well. Meantime, SBAU Astro Hour number 207. You do the math. There's 52 weeks in a year. We've done 4 years after next week's edition, our next episode, and then we start our 5th year. I love it. We'll see you all guys at different outreaches. Tell your wives and family hello, and thank you very much for joining us on the SBAU Astro Hour, everybody. This is Ronnie and Drew.
Bye.